So this lesson is all about the idea of simplifying expressions, and particularly we're looking at simplifying expressions by combining like terms. Now, importantly here is that we're talking about expressions and not equations. These are just combinations of numbers, variables, and operations without an equal sign. We'll talk about solving equations in later video lessons, but right now we're just looking at simplifying expressions, and we're talking about what's called combining like terms. Now, before we get into exactly what combining like terms is or what we're talking about, let's take a quick look at the distributive property, but this time we're going to add the caveat that we have variables involved. In the distributive property lesson, we talked only about the distributive property with numbers. Now we're going to talk about them with variables. So in our example on the left, 5 times the quantity 3 plus 6, we know that for the distributive property, we take the integer or variable or whatever it is outside the parentheses and multiply it by both the first and second, and if necessary, third, fourth, fifth, etc. numbers in the parentheses. 5 times 3 and 5 times 6. Once we've decided what those are, particularly 15 and 30, then we bring down our operation from the parentheses. This is a plus. So this is a plus. 15 plus 30 equals 45. And we can see that's true by double checking against 5 times whatever 3 plus 6 is, which in this case is 9. 5 times 9 is 45. Now the exact same idea applies to any distributive property problem involving variables. And really, the distributive property is most often used when talking about variable expressions. So 5 times x and 5 times 7. Now 5 times 7 is the most obvious one immediately. 5 times 7 is 35. But 5 times x is not immediately obvious. 5 dot x. We know we have to take our plus sign down. So it's 5 times x plus 35. Now 35 is what it is. It's the number 35, and we really can't simplify 5 times x anymore. But what we do is we eliminate the multiplication sign and just write it 5x. 5x represents 5 plus x. Keep the addition sign, and we have 35. 5x plus 35 is what the distributive property says is the same thing as 5 times x plus 7. And in fact, it is the same as 5 times x plus 7. So now that we have that idea, that when we multiply a number by a variable, we don't include the multiplication sign in between, we can start looking at combining like terms. But first we have to understand what like terms are. Well, anything in a variable expression, each part, those things that are added or subtracted together are called terms. So 5x is a term. 12x is a term. If we added a 5x plus 12x plus 3, 3 would be a term. And terms that have identical variable parts, doesn't have to have identical numbers, but identical variable parts like 5x and 12x both have 1x and only 1x and no other variables. They are called like terms. So 5x and 12x are like terms. Now the question arises, what can we do with this? We have a 5x and a 12x. They have identical variables, and we know that we can do this thing called combining like terms. Well, before I tell you what we can do with combining like terms, go ahead and pause the video and see if you can discover something for yourself as a way of thinking about what is 5x plus 12x. And I'll give you a suggestion if you want to take it. Remember that 5x is just x added to itself 5 times. 12x is just x added to itself 12 times. So if we have x 5 times plus x 12 times, how many x's does that give us in total? Well, if we take the suggestion that we had, 5 x's in the red, x plus x plus x plus x plus x, that's 5. Now we're going to add on to it 12 x's in the dark bluish green, x plus x plus x plus x plus etc., etc., etc. to get to 12. We're now adding together more than 5 or 12 x's. We're adding together 17. And since we know that multiplication is just addition repeated several times, just called repeated addition, we have 17 x's that we're adding together, which gives us 17 times x. If you think to yourself for positive numbers like this where you're adding, x could be an object, like an orange. I have 5 oranges and I'm adding 12 more of the same thing, oranges. How many do I have now? 17. So 5x plus 12x equals 17x because 5 plus 12 is 17. Let's take a look at another example. 5x minus 12x. Well, if we take the same idea, we have x, 2, 3, 4, 5. I'm not going to add the plus signs in the middle because we get the idea that they're there. That's 5x. And now in red, I'm going to add the 12x that we are subtracting. Remember, these are negative x. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 5x that we're adding and 12x that we're taking away. Well, we can look at these 5x's here as canceling each other out. Add an x, subtract an x. I don't care what number it is or what it is. If you add one of something and take the same thing away, you're left with 0. The same thing is true for each of these 5. Now they're gone. And how many are we left with? Well, we're left with 12, because that's our biggest number, minus the 5 that we canceled for it, and we're left with 7 x's. But it's not 7 x's because these are x's that are being subtracted. It is then negative 7 x's, or more properly, the opposite of 7x, because x could be negative. So looking at that in a bit more, in a bit simpler form, we have x 5 times minus x 12 times. That gives us these 5, canceled with these 5. Get them out of here, and we're left with just our negative 7x's, or the opposite of 7x. One important thing that we're looking about that we're going to use from here on out is the idea of a coefficient. And a coefficient is the number multiplied by a variable. In this case, 5 is the coefficient of 5x. And because coefficients include the negative or positive going on with it, and we know that subtraction from our subtracting integers lesson is just a add the opposite plus negative 12x, this coefficient is actually negative 12. And this coefficient is 5. So some other examples of things with coefficients: 3x, the coefficient is 3. Negative 7x, the coefficient is negative 7. 11 halves x, the coefficient is 11 halves. And finally, x, the coefficient is 1, because a single variable is that variable multiplied by 1. So to combine like terms in any sort of distributive property problem, when you have variables, you just have to follow these. You must simplify only like terms, that is, the like terms that have the identical variables. So what you do is you add the coefficients, remembering that some coefficients could be negative. So add the coefficients of one set of like terms. Let's say these are the terms with x's. You're going to add those coefficients together. There could be as many as 10 or 12, or as few as 2 or 3. That is your new coefficient. Your new term with that identical variable has that new coefficient. So if we had 3x plus 5x minus 2x, 3 plus 5 minus 2 is 6, is our new coefficient. These are our old coefficients. There's our new coefficient, and it just has an x. This is our new term. Step number 3, discard all previous terms, which means get rid of these. Just keep the 6x, and that is your new term with x's. You have combined all of the previous terms, and you don't need them anymore. They're all contained in the 6x. Repeat the process if necessary. Maybe we have 2y minus 3y. If we have 2y minus 3y, we have 2 minus 3 is negative 1. Negative 1y is our new term. Take these, the previous terms, and throw them away, and all we're keeping is negative 1y. So let's see an example of that in something a little bit bigger, combining some distributive property with some like terms. A number without a variable, an important vocabulary term. We might just call it a number, but in math it is called a constant term, or just a constant. It does not have a variable. That variable does not change. The 10 in this case is a 10 no matter what x is equal to. So 10 is a constant. See if you can figure out what happens with this one. Going to have to use some distributive property and some combining like terms. Go ahead and pause the video and come right back. Well, we need to start with the distributive property, 7 times x and 7 times 3. 7 times x is just 7x. Bring down the plus sign. And our 7 times 3 is now 21. We're going to keep, I'm going to write it in red now because it's a like term, minus 4x plus 10. Now 7x and 4x are like terms. So we need to think to ourselves, 7 minus 4. 7 plus negative 4 is equal to 3. That 3 has an x on it because 7 and 4 both have x's. And we're going to get rid of these terms. We just are left with 3x. Now we have two numbers. Now these are constant terms. We would add these two numbers naturally anyway if we saw them, so we're going to add them here. 10 plus 21 is 31. Very simple, very familiar work. 7x plus 3 minus 4x plus 10 is 3x plus 31. So now go ahead and pause the video one last time. Go through these. There are some distributive properties here. Keep track of your negatives. Make sure you know what's going on there. And some combining like terms, and come back when you're ready to see the answers to numbers 1, 2, 3, and 4. Well, for number 1, our distributive property first says negative 3 times x, which is negative 3x, plus, because we keep the plus, negative 3 times 4 is negative 12, minus 12. Now I intentionally put the 12 there so that if you forgot to multiply the 4 by a negative 3, you would cancel the 12s, but in this case you don't. It is 2, because we remember that subtraction is adding the opposite, is 2 negative 12s. So negative 3x has no like terms. It just remains how it is, plus a negative 24. For number 2, we have two distributive properties to do. I'm going to go ahead and erase the 2 so we can have some room down here. We have two distributive properties. 4 times x is 4x, plus 4 times 1 is 4. I'm going to do this a little bit vertically, because now we have minus 5x plus 2, which is really this distributive property. So we must remember that that 5, even though it is subtracted and has no negative sign attached to it, is actually a negative. Add the opposite. Is negative 5 times x plus 2. So it is negative 5x plus negative 5 times 2 is negative 10. Now we're looking combining some like terms here. 4 plus negative 5 is a negative 1. So that is either negative 1x or negative x. And 4 plus negative 10 is negative 6. Circle these here so we can see what we're looking at. And so our final answer is just negative x plus negative 6. Now number 3, our distributive property is at the end. 2 again is negative, so we have to remember that this is negative 2 times b plus negative 2 times 1. Then we have our 4b minus 2. 4b minus 2b. 4 minus 2 is a positive 2, so 2b. Negative 2 plus negative 2 is negative 4. Add all of these terms together and we get negative 2b plus 4. And finally for number 4, no distributive property, just combining like terms. 2n minus 3n is negative 1n. 2p plus 6p is equal to 8p. So one more time, when you combine like terms, you just find the terms that have the exact same variables. You combine their coefficients by adding their coefficients together and making sure you keep track of which ones are negative and which ones are positive. Add the variable again, and that is the new term, and you can throw away all the old ones. Repeat however many times are necessary. You might have some n's combined with some p's. They are not like terms, but they can be, the n's and p's are not like terms, but they can be combined with the p's within themselves and the n's within themselves. And that is how you simplify an expression, by combining like terms.